When you listen to a professionally recorded song, it could be a massive pop hit or maybe a really minimalist jazz trio.
Right.
You're hearing something that's fundamentally different from just a live performance. It's not just a copy of the music.
Huh. It's an engineered product. And our mission today is to really get inside the engineering and, well, the architecture behind that transformation.
Yep.
A modern studio is built for this high-precision recording and mixing. That means you're basically fighting the physics of sound every step of the way.
So let's start with the literal foundations then, because the space itself is really the first piece of equipment.
It absolutely is. And a studio is generally split into two very distinct environments. You have the live room and the control room.
The live room, that's where the musicians are actually playing.
Exactly. And the design of that space is often kind of counterintuitive. Sometimes you'll see these really high ceilings, and that's on purpose.
To give the sound some room to breathe.
Precisely. It lets the sound waves from something big, like a drum kit, develop naturally before they even hit the microphone. It gives the recording a real sense of depth.
And these rooms aren't just static, right? They can actually be changed. I've seen these large movable panels on the walls.
Yeah, they let you manipulate the physics. An engineer might want a really bright, reflective sound for a punchy drum track.
So they'd flip the panels to a hard surface.
Right. Or they could flip them to a super absorbent side for, say, a warm acoustic guitar. They're literally tuning the room like it's another instrument.
Okay, so this brings up a really important point. We need to clarify two concepts that sound similar but are totally different: soundproofing and acoustic treatment.
Yes, this is crucial. Soundproofing is purely structural. It's about stopping sound from traveling through the walls.
So keeping the traffic noise out and the loud guitar amps in.
Exactly. And you do that with mass. Thick concrete, air gaffs, specialized rubber layers. It's all about isolation.
So soundproofing is isolation. Then what is acoustic treatment? Because that's about what happens to the sound that's already in the room.
You've got it. Acoustic treatment is about controlling the behavior of the sound the musician makes. Without it, you'd just get a mess of echoes. The music would sound hollow and muddy.
And we use a few main tools for that. I think the most obvious ones people see are those big absorption panels.
Yeah, those foam or fiberglass panels. Their whole job is just to soak up reflections, mostly in the mid and high frequencies, to stop that slapback echo where notes just smear together.
But the low frequencies, the bass, that's a whole different problem, isn't it? Those long sound waves are much harder to control.
They really are. Low frequencies love to build up in the corners of a room, and that creates this booming sound that isn't really there in the source.
So how do you fix that?
You install bass traps. These are big, dense units that go right in the corners and just dissipate that low-end energy. If you don't have them, the kick drum you record will sound all bloated and awful in someone's car.
And then, on the complete opposite end of absorbing sound, you have diffusers.
Right, the ones that look like weird geometric blocks on the wall.
Yeah.
They don't absorb sound, they scatter it. Because if a room is too absorbent, it sounds unnatural and kind of dead. Diffusers keep some reflections in the room, but they spread them out randomly, so you get a sense of air and life without any bad echoes.
And the whole point of all this work is to make sure the song sounds the same in the studio as it does on your headphones at home.
That is the goal.
Yeah.
A predictable, accurate environment.
Okay, perfect environment is set. Now we have to actually capture the sound, and that all starts with the microphone, the thing that turns air vibrations into a tiny electrical signal.
And in the studio, you're mainly going to see two types. First, you have dynamic microphones.
These are the tough ones.
These are the tanks. They're incredibly durable and can handle really intense volume without distorting. That's why you put them on a loud guitar amp or right up on a snare drum.
And then for more delicate sounds.
Then you move to condenser microphones. These are more like sensitive surgical tools. They need external power, what we call phantom power.
And that lets them be more sensitive to subtlety.
Exactly. Their diaphragm is much lighter, so it can react to very small changes in air pressure. This makes them perfect for vocals, or the shimmer on cymbals, or a detailed acoustic guitar.
And when you're recording vocals with a condenser mic, you always see that little screen in front of it, the pop filter.
Oh, always. That screen just stops the harsh blast of air from words with P's and B's, we call them plosives, from hitting the mic and causing a horrible thumping distortion.
So now we have this tiny electrical signal, but it's weak and it's still analog. How do we get it into the computer?
The first stop is critical. It's the preamp. Think of the signal from the mic as a whisper.
Okay.
If you try to record that whisper directly, you have to turn the volume up so high later that you also bring up all the background hiss and noise with it.
Ah, so the preamp boosts the signal early and cleanly.
Perfectly put. It boosts that weak signal to a strong, usable level before anything else happens. And a good quality preamp does it without adding any noise of its own.
From the preamp, the signal then goes to the audio interface.
Right. And this is the bridge. This piece of hardware takes that strong, amplified analog signal and converts it into digital code, the ones and zeros that your computer software can actually read and work with.
That analog to digital conversion is so essential. And this whole journey is happening through cables. For microphones, we always use that 3-pin XLR cable.
Yes, and the XLR is so important because it's a balanced cable. It has 3 wires. 2 of them carry the audio, but 1 is phase inverted.
So it's carrying an opposite copy of the signal.
Exactly. So any interference that hits the cable from a power cord or whatever, it hits both signal wires equally. Then at the other end, the gear flips that inverted signal back into phase.
And when it does that,
The 2 identical interference signals cancel each other out completely. It's an incredibly clever way to get a perfectly clean signal, even over a long cable run.
wow. So the silence in a studio isn't just the soundproofing, it's electrical engineering inside the cable.
A huge part of it is, for guitars, you usually just see the standard 1/4-inch cable. But there's a golden rule for all of them.
Keep your audio cables and your power cords away from each other.
Far away. If you run them parallel, you are guaranteed to get a constant 60-cycle hum in your recording. And that is a nightmare to try and remove later.
Okay, so now we move into the brain of the operation,
Sure.
the control room. It's separated from the live room by that big, thick window.
And the engineer sits in one very specific spot. It's called the sweet spot.
Why is it so specific?
Because it's the one place where the sound from the left and right speakers arrives at the engineer's ears at the exact same time. If you move even a few inches, the whole stereo image and frequency balance changes. All the critical decisions have to be made from that one chair.
And right in front of them is the command center, the giant mixing console.
Right. And each one of those long vertical strips on the board is called a channel. Each channel controls one microphone or one instrument. You could have 60, 70, even more channels for a big song.
And on every single one of those channels, you're mainly controlling 3 things. The first is obvious, the fader for volume.
Yep, just balancing how loud everything is. The second is the pan knob.
Panning.
Hmm.
That's moving the sound left or right in your headphones.
Exactly. It creates that wide, immersive stereo image. And the third, and maybe the most creative control, is equalization, or EQ.
EQ. This is where you adjust the tone, right? The bass and the treble.
It's way more specific than that. It's about surgically shaping the frequencies within a sound. For example, if an acoustic guitar sounds a little dull, an engineer might boost the high-mid frequencies to add some sparkle.
Or if a kick drum is too thin, you could boost the super low frequencies to give it more punch.
Precisely. Or you might do the opposite. You might cut some mid-range from a bass guitar so that it doesn't fight with the singer's voice. EQ is all about carving out a specific space for every single instrument to live in.
But these big consoles now work together with the real brain of the modern studio, which is the software, the Digital Audio Workstation, or DAW.
The DAW is everything. Think of programs like Pro Tools or Logic. They completely replaced old tape machines.
Because you can edit things non-destructively.
Exactly. The software shows you the audio visually as waveforms. You can zoom in, see a breath between words, and cut out a mistake with perfect precision. Things that were just impossible on tape.
And the DAW is also where you use all the virtual effects, the plugins, reverb, delay.
All of it. And because that software has to run dozens, maybe hundreds of audio tracks, each with multiple high-quality plugins running at the same time, the computer has to be incredibly powerful.
Which raises a good question. If the software is so perfect and powerful, why do big studios still have those giant, expensive analog mixing consoles? Is it just for show?
It's a great question. Part of it is workflow, but a big part of it is sound. Analog gear introduces these very subtle, pleasing, harmonic distortions, a kind of warmth or richness.
A character that digital can't quite replicate.
Some engineers feel that way, yes. So while the DAW gives you perfect recall and editing, the console adds that little bit of sonic signature.
Okay, let's walk through the whole journey, from idea to finished song. It starts with the first step, tracking.
Tracking is just the process of recording the basic parts. Usually you start with the rhythm section, the drums, and the bass. They provide the foundation, the grid for everything else.
And once that foundation is down, you start building the song with overdubbing.
Right. This is where you add new layers on top of what you've already recorded. The lead vocal goes on, then the backing vocals, then the guitar solo. It allows one person to sound like a whole band.
Now, during all this tracking, the engineer has one major technical rule they have to follow.
Yes, they have to watch the recording levels like a hawk. The signal can never ever be too loud. If it is, it will clip.
And clipping is bad. Why is it so catastrophic?
When a signal clips, the top of the waveform literally gets flattened out or squared off. This creates this horrible, buzzy digital distortion. And the crucial thing is, it's irreversible.
You can't fix it later.
You can't. You have to throw the tape away and do it again. That's why engineers are so careful with their levels.
Okay, so all the tracks are recorded, nothing is clipping. We have maybe 100 individual tracks. Now the project moves into the next big phase, mixing.
Right, and mixing is where you go from a collection of parts to a cohesive piece of music. It's much more of a creative audio painting process.
And here, one of the most important tools is compression. People hear that word a lot, but it's often misunderstood. It's not just about making things louder.
No, not at all. A compressor is basically an automatic volume control. It reduces the dynamic range, the difference between the loudest and quietest parts of a performance.
So for a singer, it would turn down the shouted words and turn up the quiet ones.
Exactly. It makes the overall volume much more consistent. And that consistency is what helps the vocal sit on top of a busy mix so you can hear every word clearly.
But it's also used as a creative tool, not just a technical one.
Oh, absolutely. Heavy compression can completely change the character of a sound. You can smash a drum set with a compressor to make it sound incredibly powerful and punchy. It's the glue that makes everything feel like one unified wall of sound.
So the mix is done. Everyone's happy.
Yeah.
It moves to one final, often mysterious step: mastering.
Mastering. And this is usually done by a different engineer in a different studio with fresh ears.
What's their job?
They have a couple of key jobs. First is to set the final overall volume of the song so it's competitive with every other song on Spotify or the radio. We call it commercial loudness parity.
And the second job?
Translation. The mastering engineer checks the song on everything. Tiny phone speakers, big club subwoofers, cheap earbuds.
To make sure it sounds good everywhere.
To make sure the mix translates and sounds professional on any system a listener might use. It's the final quality control check.
So the journey of a great song really relies on both a brilliant performance and the meticulous technical skill of the engineer shaping that sound.
Absolutely. A professional track isn't just recorded, it's engineered from the ground up. Understanding the acoustic treatment, the preamps, the EQ, the compression, it shows you that what you're hearing is a carefully constructed sonic experience.
So here's something to think about. If we can now capture and edit sound with, flawless digital precision, what place is left for those random human imperfections, the so-called happy accidents, that really define the character of music recorded on old analog tape?
Good luck with your studies.